Hello, it's me again. Today's subject is connections. So we have been rushing through the different parts of a house, which is roof structures, maybe a flat roof, then we have ceilings and floor slabs, then we have the bottom slab here, we have foundations, and we had vertical load-bearing constructions. And now we will take care of how things meet. So we have two big phenomena here that we have to take care of. One is gravity, and the second is how to keep things in place, a fixation. So if I have, for example, a concrete floor slab, it will hold on the wall by itself. It takes a certain surface to transmit the load in the wall, and then I have to keep a little distance here, has to be able to insulate it. But one is gravity, how to put the load of this floor slab on this wall, and the second is to keep it in place. So for a concrete floor slab, that's not a big problem because it interlinks nicely with the wall building material. So if this consists of wood, then we might work with niches. We have a niche in which we put a wooden beam, and then the connection becomes a problem here. And very often people have a tendency to say, I need a circular beam so that the whole construction can rigidify the box-like structure of the house. So this would then be the primary beam. I might have secondary beams, and I might not be put upon, so that gravity and maybe a nail for fixation is enough. They might be in between the primary structure as well. If this is the case, I will have to create a connection between secondary and primary construction, and for this traditionally I often use metal connectors. So this often helps to create a connection, although it's not always what I want aesthetically. So the one solution would be a joist hanger. We will take a look at those afterwards as well, which is a metal plate here, and it has holes on the side so that I could put nails in these holes and thus connect a secondary beam to a primary beam. On top here, that's a nail plate to link one piece of lumber to another one in a horizontal level. So one piece of lumber here, the other here could be put together with a nail plate. Then we have different dowels here, dowels that assure connection of two pieces of lumber, which are in different levels. One, for example, in this direction, the other in this direction. You put this in between as to guarantee that transmission by horizontal connection is possible. Here you have joist hangers of different kind corresponding to different types of solicitation. Here these are hidden inside, that you don't see the metal on the outside, which is important for certain types of utilizations. A big bolt as well, and a dowel which would be put through a metal connector like this as to create a horizontal support. So here you can see some articulated joints. For example, this is the foot of a wood column, and you can see that this counts as being articulated because it's so slim in comparison to the wood column that would come above. Here you have a swallowtail link between a horizontal element and a vertical. Same here. You can nail these on the different elements. And here you have a diagonal. And this diagonal will be linked at the angles to the wooden skeleton. Today, with CNC milling, I have other possibilities. If I don't want to see the metal joist hanger, I could also use swallowtail connections. This would mean that I have a negative here, which would be something like this, milled out of the timber beam. And then I would have a positive nose here, milled out of another timber beam, and then this would slide inside the first. So for the connection of a sloped roof and a vertical load-bearing element, it might be decisive what type of roof construction I've been choosing. If I have a purlin roof, I don't have a horizontal thrust here at the bottom. But for a rafter roof, I will have to take this horizontal thrust with the corresponding detail. So this corresponding detail should be able to take this horizontal thrust and to link these lean-to elements to each other. What I've been drawing here is a concrete floor slab and wooden roof construction. I could use beams as well, and then I might have a step joint here to transmit the load of the rafters in the ceiling beam, and the ceiling beam would lay on the masonry in one way or the other. I need a certain length to prevent the timber from splitting up through the horizontal thrust, and then I could add another element as to create continuity for the roofing material. Now, if I want here again use the horizontal element as a rigidification for the structure as a whole, if I want to create a slab, I could also say once again I want a ring beam at this spot here. So the rigidity is created by the ring beam itself. That's considered to be rigid, and this takes away the question of rigidity from the roof construction. So in the purlin roof, this connection can be less complicated. I have the lower purlin, and then I have the rafters on top of that. And here once again I'm creating a step joint to assure that by gravity the rafter can rest on the purlin, and then I might secure it with a nail diagonally so it is not lifted up by the wind. So now I can either put this on a wall, or I could continue here. The base purlin, put it on columns, and create a wooden wall construction. So here, in the example of a purlin roof, you can see that the horizontal structure of the roof rests on what I would interpret as walls, and you have a floor slab that consists of wooden beams, and then the roof structure is integrated in these wooden beams. What they have been trying here is to integrate the bracing in both directions, as well in this connection between the beam and the rafter structure. So when it comes to the ground, I will have to transmit the load to the ground, and I will have to spread it on a wider surface as to guarantee that the maximum admissible tension of the soil is not overreached, so that the soil will break. So I have been introducing a foundation, and I also need a support for the bottom floor slab, which today very often rests directly on the ground. So if I distance this a little, I can introduce a layer of gravel here underneath, and I ensure that this horizontal slab rests on the gravel and not on the side of the foundation. Another solution would be to link both of them. So if I'm linking them, I can get up a little, and what is often done for convenience is to create a little slope here in the floor plate, as to create a better correspondence to the vertical load that is meeting this floor plate here that rests on the ground, so as to solidify this in a better way. I'm integrating the foundation in the horizontal base plate. So up to now we've just been speaking about load transmission, and there might be other criteria, like insulation can be an important factor, and waterproofing might also be an important factor. So for example, if I have groundwater, it might be necessary to create a continuity between a vertical concrete wall and a horizontal concrete base plate, and then this continuity here has to be assured with the special jointage that we will discuss in another conference. Load transmission, I think